Hello students, today we are going to discuss projectiles. So when we are going to start projectiles, we need to know that what is projectile. Projectile is something that can be thrown, projected. And when we talk about the projection, this projection can be of three types basically. One is vertical projection, one is vertical projection, second is horizontal projection, third one is angular projection. It is vertical projection, horizontal projection, and angular projection. So let's start with the horizontal projection, this one, because the vertical projection has nothing uh, important to do with, because whenever the object is vertically moving, that means its motion is only in one dimension. If the object's motion is only in one dimension, then it is either falling downward or it is rising upward. So we are making use all of the equations of motion just as it is. V equals to U plus gt, S equals to ut plus half gt squared, and V square equals to U squared plus twice gs. Here S is h, the vertical height. So we have nothing to deal with a lot of thing about the vertical projection because the object is just restricted in one dimension. So one dimensional motion. When we talk about the vertical projection, it is just one dimensional projection. But right here, when we talk about the horizontal projection, so when we say it is horizontal projection, the object's movement, the motion is not restricted into only a single plane, single dimension. Rather, the object has a two-dimensional motion. Suppose right here the object is, and this object has been projected along this direction. So this is the horizontal velocity with which it has been projected. It is projected, as you see, some height above the ground. So this is suppose h, some height above the ground. The object has been projected, and the object eventually falls back to the ground. It has been projected horizontally, exactly horizontally, but due to the gravity, the object falls back to the ground, and this is somewhere it hits the ground. So the object's motion here is not restricted in only a single dimension, rather it has a two-dimensional motion. The object is both traveling horizontally and vertically. It has vertical displacement of h, it has horizontal displacement of say x. The object has both the horizontal and vertical motion when object has been projected horizontally, because we cannot seize the gravity. Though we projected the object with horizontal velocity, the object is no longer going to continue its motion in only horizontal direction. So object is eventually going back to the ground and hitting the ground somewhere at this point. So the object has both the horizontal and vertical motion. So this is what we are going to now deal with, that if the object has been projected horizontally, what are the things we have to look at? So we will be just considering these equations of motion, which is mass independent. And one more thing is we are representing the equations of motion right here, saying the object has a constant acceleration. If the object is falling down, it is constantly accelerating downward. If the object is going up, it is constantly decelerating. So it has under the constant acceleration or deceleration effect. That means G value is same. Why the G value will remain same? Because no air resistance is being considered. So since no air resistance is considered, so the acceleration is not going to change. The acceleration remains the same. and this allows us to use these equations of motion. So no air resistance is considered in our entire projectile chapter while doing the maths. So if the object has been projected horizontally, this is the velocity with which it has been projected, and due to this horizontal velocity, the object travels some horizontal distance of x. So this much has the horizontal distance of the object, and this much is the vertical displacement of the object from where it was projected and at where it hits the ground. We have to keep this in mind that horizontal and vertical, they are independent to each other. Vertical and horizontal are independent to each other. Independent. What does it mean? It means if something acts horizontally, it does not have any effect along the vertical direction. If something acts vertically, it does not have any effect along the horizontal direction. Suppose the g, acceleration due to gravity, that acts vertically downward. It doesn't have any component, any effect along this horizontal direction. So what is the g value right here? It is 0 absolutely. What is the g value right there? 0. G is acting vertically downward. It does not have any horizontal component, horizontal effect, horizontal value. Similarly, when I threw the object horizontally with this VH velocity, so this VH has no component along this vertical direction. So neither downward nor upward. The vertical component of this horizontal velocity is absolutely 0. So right here, when the object has been projected, its initial vertical velocity is 0. Its initial vertical velocity is 0. So if I say this is u is the initial velocity along the vertical direction, this uv is 0 right here. But due to the gravity, it is accelerating downward. So as time goes on, the vertical velocity will keep increasing. So suppose after 1 second, this is somewhere the bodies, and this will have the some initial velocity. So this vertical velocity, the initial velocity is absolutely 0 right at this point where it was projected from. But vertical velocity is increasing right here. So this vertical velocity is this much. Horizontal velocity stays the same as before. So this velocity, it is constant all through because there is no air resistance. Next second, suppose this is where the ball is, and its initial vertical velocity even increases, but the horizontal velocity stays the same as before. And the point when it hits the ground, its horizontal velocity still stays the same, the vertical velocity is maximum, and this is the final vertical velocity. So initial vertical velocity is 0, the vertical velocity keeps increasing, and this much becomes the vertical velocity finally when it hits the ground, and it is maximum right here. So this is just the case when the object is just falling freely from some height. Initial velocity is 0, so this initial velocity starts from 0, and this velocity increases, and this is where when it hits the ground, this velocity is maximum. So this is how the vertical velocity, which is independent of the horizontal velocity, is increasing at the rate of g, because g is acting vertically downward. So g is acting vertically in vertical direction. So the vertical velocity is also increasing at the rate of g. The horizontal velocity stays the same. So we are considering the vertical motion and horizontal motion independently. When we consider the vertical motion, we are just considering all the vertical parameters, all the things that are acting vertically. That is the vertical displacement h. That is the vertical velocity which is acting. So this vertical velocity, this one. all the vertical velocities we can take. We can consider the vertical acceleration. These are the parameters that we can take. And we can also consider the time. So time is a scalar quantity, but here time we can consider because the object takes time t to reach right here, traveling this much vertical distance or vertical displacement, whatever you say. So the object travels this much vertical displacement h covers at time t. So time also can be included both for the horizontal and vertical motion. But all other vector quantities are considered to be separate. For horizontal motion, what are the things acting horizontally? The horizontal velocity, horizontal displacement. These are the horizontal vectors, so they are under the horizontal motion. The vertical quantities, suppose vertical displacement, vertical height, vertical acceleration, these are right here going to be under the vertical motion. And as you see, since there is no air resistance, the horizontal velocity stays the same. So there is no change in horizontal velocity. It neither decreases nor increases. So there is no acceleration. So in horizontal motion, we are not going to consider any kind of acceleration. So these are the equations that we are considering for the vertical motion, just for the vertical motion, which is h equals to the initial velocity uv t plus half gt square. And in this case, our initial velocity is 0. The object has been completely projected along the horizontal direction. So this turns to be 0. So the equation comes to be h equals to half gt square. T is the time of flight. T is the time of flight. T is the time the object takes to hit the ground right there. And when it hits the ground right there, how much vertical displacement the object covered? This is h. So when we are considering the vertical motion, we are just considering the vertical quantities. That is something to be uh, kept in mind where you need to pay attention to be paid. So number 2 is the vertical quantities. How are going to be these vertical quantities uh, used in this vertical motion? So this is another equation. The vertical velocity, the final vertical velocity is initial vertical velocity plus gt. So this is the v equals to u plus gt. Right here, we have become very much specific. This v is vertical velocity final, uv initial velocity final, I'm sorry, vertical velocity initial plus gt. So this is Vv equals to uv plus gt. Here again, this is 0. So Vv, the final vertical velocity, which is maximum right here when it is going to hit the ground, it is gt. T is the time of flight. Number 3 is Vv square equals to uv square plus twice gh. The h is the vertical height or displacement. So here again, the initial vertical velocity is 0. So the final vertical velocity Vv square equals to twice gh. So if we subject Vv, it is going to be root over 2gh. So these are the things will be considered when we consider the vertical motion. So right here we cannot include the horizontal velocity because horizontal velocity doesn't act vertically. Horizontal and vertical, they're independent to each other. Many students, they make the mistake right here. They use uv right here as the vh, the horizontal velocity. They put down this horizontal velocity value right there and they do the sums. But those sums are not going to be correct. So this is how they lose their marks. When we consider the horizontal motion, we are going to consider all the horizontal quantities, horizontal vectors that are here used. So right here for horizontal motion, we can say the horizontal displacement x equals to horizontal velocity times the time of flight. Because at this time, the object simultaneously travels this much horizontal distance as well. It travels h amount of vertical displacement, and parallelly it travels x amount of horizontal distance as well. And this is why this time t and this time t is the same time, which represents the time of light. This t is time of light. So this time of light is being used right here in this equation, x equals to vh times t. The object does not have any acceleration or deceleration because there is no air resistance. The horizontal velocity stays the same. So here there is no g, only x equals to vh times t. And this is going to give you the formula, the equation for the horizontal motion. There is no another equation that is particularly uh, to be included in the horizontal motion, because along this horizontal plane, only these two quantities are acting, or two quantities are uh, included. One is horizontal velocity, and there is horizontal displacement. So that's all about our horizontal motion. I hope you understood. Let me know if you have any queries on it.